Hi everyone, we're going to go on what may feel like a little bit of a sidetrack, but we will tie it back in with the critical values, local maximum stuff that we had earlier. So I just want to look at this function. I chose a nice cubic polynomial, and I want to make a sign chart for its derivative. Sign chart just describes when something is positive, negative, or zero. So when the derivative is positive, negative, zero, I want to show that on number line is the typical way. Okay, so if I want to do that, it seems like a good plan to find the derivative. Okay, so we have sum and difference rule first. 2x cubed, the derivative is going to be a 6x squared. And then 3x squared, the derivative is going to be a 6x. And then 12x, the derivative is going to be 12. So there's my derivative. And usually the best place to start for a sign chart is with the zeros, or undefineds as well are good to put on your sign chart, because if you're trying to decide when something is positive or negative, it narrows down a lot of the checking that you have to do if you know when it might possibly switch from being positive to negative. The only way for something to switch from being positive to negative, so this is negative y values and positive y values, is you either cross through the x-axis, so you would have a y value of 0, or you could somehow jump across, so like an asymptote is an example. So if the function is undefined, and in this case by the function I really mean the derivative, if the derivative is undefined, there could be something weird happening where it'll switch from positive to negative or vice versa, and if it's 0, then it could switch as well. But remember, 0 could also stay the same if it bounces off. Okay, so we're going to set this one equal to 0. We're also going to ask ourselves, is it ever undefined? And the answer is no here. This is a nice quadratic. It's defined everywhere. Domain is all real numbers. So let's see. I'm going to factor out a 6. And I have an x squared minus x minus 2. And then I can factor even more. I want an x minus 2x plus 1. Which means x is 2 or negative 1. Okay, so starting my sign chart, this sign chart is going to summarize, it's a number line. The number line represents all the x values, and then up above I'm just going to jot down some information about f prime. So I know that when x is equal to, here we'll put 0 in the middle, but that's not a rule. You don't have to put 0 in the middle. When x is equal to negative 1, f prime is 0, and when x is equal to 2, f prime is also 0. Okay, so that's my starting place. List everywhere that your function, in this case the derivative, is 0 or undefined. So whatever you're trying to make a sign chart for, figure out when it's 0 undefined. And then this is the really key part. If you've been very careful about this, then the only time that f prime could change signs is at these 2 points. So these are my critical numbers for my original function. And that means that if I check over here and I find out that f prime is positive, I know it stays positive forever because there's nowhere for it to switch. And the same thing within the middle. If at 0, f prime is positive, then it has to stay positive or negative. And then the same thing out here on this side. So now it just boils down to plugging in a few numbers. So you pick anything you want on this side. Negative 2 seems easy because it fits on my number line. And we're interested in f prime, so you plug it back into f prime. So we're going to have 6 times 4 minus, so it's going to end up being a plus 12, 6 times 2 minus a 12. Okay, so the 12s are going to drop out, and I'm left with positive 24. I don't really care about the number. I really just care about the plus or minus. So if you can do this without doing all the work to crunch through the value, that's fine. I just need to see enough work to know what you tested. So I do it just by marking that on the number line and what you came up with. As these get messy, sometimes what I'll do is take the factored form and say, okay, well, if I just look at the factors, the 6 is always positive. If I plug in negative 2, I get a negative 4, which is negative. And then here I get a negative 1, which is negative. So if I multiply a positive and 2 negatives, it's going to be positive. So that's another way to do it. And this is perfectly legitimate work to show me. Again, I need to be able to see what you were plugging in and then just something about how you determine what the sign was. 0 is always a nice easy one to plug in if it's not one of the critical numbers. And I'm going to go to this factored form. Actually, it's probably not the easiest. I'm going to go to this form because here when I plug in 0, all that's left is the negative 12. So f prime of 0 is negative 12, which is negative. So again, just something so that I can tell what you plugged in and how you figured this out. And then 3, this time I will use that factored form again just because it's kind of a cool way to check it. So the 6 again is always positive. 3 minus 2 is positive 1, and 3 plus 1 is positive 4. If I multiply 3 positive numbers together, I get a positive number. So this is my derivative sign chart, and I want to think a little bit about what this is telling me about my graph. So, the positive means that my function is increasing. So this is just going to be really rough sketch, but I'm going to kind of draw over the top of this what I think is happening. So the function is getting bigger and bigger and bigger and bigger, and then all of a sudden we hit a flat spot. Derivative is equal to 0. So again, this is not a picture of the derivative. This is actually f. So if the derivative is positive, f is increasing. If the derivative is 0, f has a flat spot. If the derivative is negative, f is decreasing, back to a flat spot, and then back to increasing. So this is pretty rough sketch, but I do know it's cubic, so this looks like kind of the right shape. And notice that just by following along with what the slopes tell us, increase, flat, decrease, I can figure out that this is actually a maximum. And here where we go decrease, flat, increase, this is a minimum. So I got a max and a min. So we've said that if you want to figure out where your local maximums and minimums are, you should find your critical values and investigate them. And this is one of the ways that we can investigate our critical numbers is by doing what's called a first derivative test. Okay, thanks for watching.